Good afternoon, everybody, and welcome to our very first online staff meeting for the term. I know it's been a very tiring day for everybody, especially being the first week back this term, but just sit back and listen to the presentation that I have for you this afternoon in regards to STEM and STEM education. And then at the end we can have a questions and answers if you like, and we can see where we want to take STEM education a little bit further. So just some information about what STEM is today, and having a look at some of those key areas and those key ideas of STEM, and looking at STEM education as being connected to what we are doing already, and connecting that to ideas such as inquiry learning and problem-based learning as well. So we're also going to consider a number of perspectives and looking at why STEM education is a priority and why we have that value for STEM education, and how it would look in regards to what STEM education requires of schools. So what are the challenges that are presented, and what are the benefits as well with STEM education in schools? Okay, so sit back, have a listen, and I've got a little bit of a treat for you at the end, where I present what a STEM challenge may look like in a primary school. So sit back and enjoy.
Right, so STEM education and what STEM means for teaching and learning. So just a quick introduction there of our STEM team in action in Plymouth Harbour in London. So we have our environmental educator and greater supporter of educators and teaching our students through a STEM approach, Philippe Cousteau there on the left-hand side. We have our educators in the middle, our teaching team there, and we have our marine scientists that we tapped into while we're on that STEM challenge, and looking at fisheries obviously within Plymouth Harbour and the fishing industry, and being able to create ideas and innovations that will help our fishing industry across the world become sustainable. So we tapped into the research there behind everything before we then jumped in and had a look at, well, what is the need that we see in education and where education can go in teaching our students in regards to innovations that can help sustainable practices for the future. So STEM, and what does it actually mean? So STEM is an acronym for science, technology, engineering and mathematics. So they are the standalone subjects that we bring together and teach through those lenses with our students in many different ways. So there's a quote there from White, and he says that science and maths are at the forefront of STEM education, so mainly because they are the most recognisable fields, whereas technology and engineering are often misunderstood in education, and particularly in primary education too, where a lot of those subjects seem to sort of go by the wayside. And we'll go through what those subjects actually mean and what they mean for primary education as well, in particular here in Victoria, and how we can link that to the Victorian curriculum as well. So what does STEM mean again? So according to Dr. Linda Pfeiffer from the Queensland University, she describes STEM education as subjects that are not standalone. So rather as a way of thinking. So STEM is a way of learning skills that require science, technology, mathematics, and how engineering and the design thinking process and principles are used to achieve an outcome. And through my looking at my research and looking at others' research as well, we can see that the design and the thinking processes through that engineering lens can become a very potent teaching tool for us to use in regards to teaching some of those other subjects and the ideas that can come out of those subjects as well. So the basis in which STEM education is applied in an educational setting is through students identifying a problem which is highlighted through their research in specific areas. So STEM education is also considered to be multidisciplinary, interconnected, and an integrative approach. So these approaches are both outcome focused and they aim to solve real world challenges. So authentic learning there and tapping into the interests and the motivation of our students is where we will guide that teaching and that learning. So what are the outcomes of STEM education? So we have up there's 4 outcomes that Sakeman has stated in his article, and they tap in very nicely to where we want to go with STEM education and what STEM education means for our students in the future as well. So there are skills that they can gain in these 4 areas so that they will be considered to be workforce ready in the future. So there are 4 kinds of intellectual and skill-based outcomes. So we as teachers ourselves going through this process will gain skills in teaching and in integrated and an inspirational manner. So we are asking our students to be innovative, to be creative, and to have critical thinking. We ourselves need to display that within our curriculum and our teaching and learning, okay? Scientists, engineers, and digital specialists as well. So digital specialists, who research and develop technological advances that are required for economic success and solve our global problems. So the future worker there, number 3, will be technological proficient, and they'll be able to create, design, support, and operate complex and evolving technologies within our future, and that may be in many different industries. It might be in the building construction industry with our large building constructions going on with multi-story buildings. It might be in biomedicine, and it might be looking at research into a cure for a particular disease. We might be looking at wanting our future workers to be looking through through agricultural science and crop production, and looking at drought-resistant crops. As our global temperatures warm, then so do our crops, and our food security needs to become more efficient in that kind of area as well. So we want our future citizens, our scientists, to become scientifically and technologically literate. We want them to be able to critically examine, understand, respond, and improve the world around them. So that's probably the biggest part about STEM, and I think where we need to lead STEM education is that we need to be able to respond to what is happening within the world, and we need to be able to improve that world for future generations to come. So what does it mean to be workforce ready? So employers are requiring their workers to have a set of skills in order for their employees to be competent in the workforce. So each different workforce will have a different set of skills and will suit different personalities and different learners in different ways. And importantly, though, this is a set of skills that we can generally and broadly apply to our future workers. So social and emotional resilience, so cognitive, so we need to have a literacy and a numeracy standards within our workers. We also need our future workers to have a high order thinking, that cognitive thinking there. So we need them to be critically thinking. We need them to solve problems as they arise within the workforce. And we also now need to have technical skills as well. So these are focuses, skill focus that we have here at school, in our primary school here. And, they should be future focuses as well. So, so future teaching and learning should be able to focus on these areas that we have for our future students. Also to be able to go straight into the workforce and be competent at their jobs. So having a look about what would STEM look like in our classrooms in the future. So teachers would need to set learning tasks that ask our students to design, build, test and redesign, if relevant, a problem such as litter entering our stormwater drains and entering the Port Phillip Bay. So this in turn creates a problem of plastics and microplastics entering our aquatic life through the digestive system. We would be asking our students to solve some of these problems, and we would be looking at learning tasks that would require our students to have critical thinking, to be engaged, so high level of motivation, high level of engagement for our students, and it needs to be relevant to learning and their perseverance of that learning task as well. So we would require our curriculum to be delivered in ways that encourage curiosity and reflection, combining our students' inquisitive nature and combining this with powerful scientific, engineering, technological and mathematical methods as well. So just highlighting that picture there by Earth Echo International, and that was another expedition that involves teachers going on a scientific gathering in a sense, and looking at and immersing themselves within that environment that we're going to study, and to be able to develop our teaching and learning areas there. And that is something that we would want our students to be able to possibly achieve and have that exact same experience that Earth Echo provided for us as teachers there in 2018. So you immerse your students with the environment first, with the issues first, and allow them to come to a realization that there are some problems here and where those problems need to go. So that's where we need to start setting our teaching and learning as well, to encourage that curiosity. So we're just going to move on a little bit and have a look at technology and engineering. They are two of the subjects that are often misguided, misplaced in a sense, or there's a lot of misconceptions around these areas of study. So technology is often confused, and many people, when they think of technology, will think of the digital technologies that are tools or methods. So we generally think about computers as such, and you can see that in the picture there of our teachers learning about some new technologies there. So technology also encompasses much more than computers. There are several different constructs, such as bio and medical technologies, building and construction, engineering and manufacturing, electronics, engineering and power, which includes sub-technologies such as automobile engines, green energy sources such as solar and wind power. So also we can look at the areas of design technology as well, which is just important when we move on to the engineering phase of a STEM teaching and learning. So technology and engineering is problem-based, and it can be defined as how humans modify the world around them to meet their needs and wants and to solve practical issues. So they may include things like designing, developing and using technologies as a tool. They may be open-ended, problem-based design activities. They need to also be cognitive, manipulative, so hands-on learning, and to have a number of effective learning strategies within those tasks as well, and apply technological knowledge and processes to real-world experiences using resources that are current, and not only working individually for our students, but they must also be able to work in teams to solve problems. So they need to have that teamwork there. So just on the right-hand side, I'll just point you to a team of students working on a STEM project. And you can see down the bottom there, you can see that they were required first up to work individually to develop and to solve some of those ideas first before coming together as a team there. So they had to go away and do their research on a particular idea, a particular theme that resonated with them. And this team decided that they wanted to look at waste and look at litter. So they decided they wanted to build a prototype of a waste receptacle for their students to use, the younger students within the school. So they had that authentic learning there. They wanted to highlight the problem of litter around the school after doing a litter audit. They were quite horrified to find how much litter they actually found that was hidden litter amongst the playground. So why is STEM education important, and what does it mean for us as teachers? So it's important to empower students to be responsible learners, to be responsible citizens of the world. And we want to encourage our students to take a level of responsibility for appropriate technological use and societal implications as well. So they will be derived from their informed decisions and ultimately their behaviour and their actions as the future generation moving through. So learning is lifelong and it's authentic, and it should involve decision making that requires our students to consider others' viewpoints as well, which is extremely important when working in teams. Students should be capable of using their knowledge for scientific, societal and environmental purposes, and this in turn creates active and informed future citizens that act on a global scale for our future. So is STEM education crucial to 21st century learners in Australia? Okay. Education for sustainable development is becoming ever present in our world on a local and a global scale. Our students of the future, and they'll be living in an environment that needs some attention and care at the present. Climate change has hit the forefront of our everyday living. And that is shown by recent bushfires in Australia, the current health pandemic encompassing our students on a global scale also highlights the concerns for active, informed citizens. And this remains a pressing priority and one that we as teachers must face in our teaching and learning on a daily basis. And as educators, we face a pressure to design curricula and implement pedagogies that develop students' disciplinary knowledge, such as science and skills, as well as increase their ability to be critical consumers, creative and ethically astute citizens, innovative designers, great communicators, and team members with high level of collaboration skills. I believe that science as a human endeavour is an important part of our work within STEM. So we're experiencing an unprecedented and unparalleled period in our history as humans. We feel we have to seek and have to control over nature. So this area, the Anthropocene, has seen the beginning of the Industrial Revolution and is characterised by the use of fossil fuels and technologies that we have developed, such as the automobile. The altering of ecological systems, climate, oceans, soils, results in changes to biological and geological systems. So natural systems that are at the mercy of our human systems that we have developed. And in recent months and weeks, we have shown a huge reduction in CO2 levels from countries that experience massive amount of air pollution and acid rain as a result. So countries that have been hit the hardest by this COVID-19, for example, China, Italy and Spain, have seen a huge reduction in CO2 levels. And NASA has been fantastic in putting that information out there and taking their photos from space so that we can visually compare and contrast before COVID-19 and after or during COVID-19 lockdowns. So that really does highlight that we as humans are using a lot of our resources to the detriment of our environment. So there lies huge issues that we can use with our students to have them future ready. So a scientific call to action. So based on what we're seeing in the world and at the moment, STEM education is a way that we as teachers can deliver curriculum that incorporates science, sustainable development of both the economy and the environment, so values education, citizenship, and global issues. It would embrace interdisciplinary ideas, develop content knowledge and inquiry skills. So we're developing socially responsible students as future citizens with developed high order thinking. And these are seen in the Australian curriculum under the general capabilities there. So we want to develop risk takers in our future, CEOs, scientists, engineers, and our country's leaders across the world. So Australian STEM school education strategy was developed in 2016. So this is just tapping back into some of that research and that theory that I've been doing over the last few weeks in order to deliver this to you. So in 2015, the 10-year National STEM School Education Strategy was endorsed by our ministers, and it had a renewed focus on STEM education with 2 goals that are listed there. So we want to ensure all students finish school with a strong foundational knowledge in STEM and STEM-related skills. We want to ensure that students are inspired to take on more challenging STEM subjects as they themselves grow through their schooling, whether it's in secondary schooling and taking on some more of those sciences, or whether it's learning to adapt themselves in their future. So there are 5 strategies for action. So this, the Australian STEM School Education Strategy asks that, we look into increasing student STEM participation. We increase our teacher capacity and quality of teaching. So we need to tap into our pre-service teachers there, and our pre-service teaching needs to become contemporary, needs to become multidisciplinary as well, and include these ideas of STEM within their pre-service teaching. So we need to support STEM education opportunities within our schools, and that is building our networks, building our partnerships there so that we can facilitate effective partnerships like the one with Earth Echo and Philippe Cousteau and his team there. We need to build a strong evidence base as well. So strong science using research and data that is already out there, so that our claims and our reasoning is grounded in strong scientific data. So some of the challenges and support for STEM education in our schools. Females continue to be underrepresented in STEM-related courses and careers, and exposure to female roles as well. So at the present, there is a push for girls in science in schools and in STEM ideas and activities. Through experience, they move on through to university level and move through their initial science course, bachelor's, and move on into further research and further study. However, when it does come to actually finding a job out there in the science-related field, it is extremely hard, and it's extremely hard for females as well. So we need to expose our students to our female role models in regards to that, so that they are confident learners within the STEM disciplinaries. So the ACER report, which was produced in May in 2018, states that STEM should be a focus as a multidisciplinary approach in schools. And students should be encouraged to engage in and participate in specialised STEM careers as well. So ACER recommends students participate in STEM education and participate in specialised STEM careers. So the establishment of schools such as the John Monash Science School here near us, and having our students go through that and looking at that STEM focus is highly important, that we are providing opportunities for our students to be able to, be able to be selected for these schools as well. ACER recommends students participate in STEM education right from early childhood education, primary, secondary, and through to tertiary education as well. And there's pre-service teacher education is another important area, which I've already mentioned, in which we need more work to enable teacher confidence to teach those higher quality programs as well. All right, so we're going to move on to just the next phase of our presentation today, and just having a look at a snapshot of STEM education and in teaching and learning in the present. And these are just some of the ideas and the experiences that you can tap into as well. We do have staff that have, been through these experiences and have that knowledge to be able to draw out authentic STEM learning. So we want to focus on the importance of high quality teacher education. So that's you guys. So learning from the experts, so pulling in those scientists. And you can see down the right hand side here, we have Dr. Firth there, who is talking about bioblocks in a marine environment and developing these bioblocks. So this is in Plymouth, in Sutton Harbour, and Dr. Firth has actually tapped into scientists from the Great Barrier Reef and looking at how the coral and the coral bleaching through acidification, and looking at what can we do. So this is true, genuine science learning that we can involve our students in. We can create and make some bioblocks with our students and use them within our local waterways to show how important they are in attracting habitat and biodiversity within our marine environment. You could also then, I know Dr. Firth looks at the marine environment, but you can also look at our local waterways as well. So looking at engineering solution, product development here. So the goal with this idea is to stop plastic at its source. And you can see there it talks about the nurdles and talks about those plastic microbeads. How can we stop those plastic microbeads that are in our environment and in our shampoos that we wash down the drains? How can we stop them from going down the drain there as well? So looking at building prototypes and tapping into people that we can use to help us build our prototypes with our students and to help them put their ideas into practical reality. So looking through science and our scientific partners here, and our women in science, and providing opportunities for them at a young age to be able to participate using the science resources and equipments that our scientists have as well. But it also means tapping in to our science research through other universities, other areas, and building those relationships there. As well as tapping into those organisations that are, providing resources made by teachers for teachers, so they know exactly what needs to happen and where they need to go. So we need to look at our teacher practice and lesson development through trial and error. So we as teachers need to be learning alongside our students as well. We are not going to know it all, and to be able to push our students further with that high level of student active participation and high student outcomes, we need to be able to have those skills as teachers to be able to push them further into research. Might be individuals research that we need to guide them through before they can then come back as a team and work in a team environment there. So they're just some of the ideas that might, help implement STEM learning and teaching in a multidisciplinary approach. So I have got for you today a little video that I have made in regards to a STEM challenge, and the STEM challenge was to draw, have a drawing implement using electric circuits. So before this task, we would have our students involved in research first, looking at electric circuits and understanding the ideas behind electric circuits as well. All right, so I'm just going to play that for you. Using a STEM approach, we are going to challenge our students to create a tool using electrical circuits to be able to draw something. So they may have seen this kind of challenge before. We give them some materials to use, and in this case we're going to add in obviously the electric circuits, so the battery, the wires. So they will need to have an understanding of the science behind electric circuits to be able to complete this task to a satisfactory level. We want to see critical thinking, we want to see innovation, and we want to see new ideas coming through in their designs. And we want a working design at the end, a working prototype. So we need to be able to scaffold our students just that little bit more by giving them some research ideas, some background ideas first. This might be accumulation at the end of an inquiry unit of work where students put together their knowledge to create a STEM approach using a design and engineering model. So sit back and watch and learn along in the process of how to create a STEM activity for our students. Okay, so now I'm going to open up to a Q&A with you today. So is there any questions or is there anything that we need to answer? So write them down and I'll give you a couple more minutes and then we can go to our Q&A chats through there. Okay, brilliant. We have a few questions, so I will end the video here and the recording, and we'll move on to some of our questions and answers, and then we will go into our stage to our next phase of our looking at STEM education. So thank you for listening, and I appreciate your attention after a hard week and a heavy day.